Zach, congrats on the first. Tyler, hey. Okay. I feel like I should switch it up to today and do diffie Qs. Well, I have been doing diffie Qs, but let's do a different version of diffie Qs. It was good, Zach. They way over budgeted for time, so we ended up taking a lot of breaks to like catch back up with the schedule. But yeah, there wasn't too much surprising or new information, but the most helpful thing they probably did was because you can't end early. No, the issue was that it was run by the program advisors, but they invited a bunch of other people to like speak at certain times, and so you can't just ask the person to show up early at the last second. So I get it. Um, yeah, so I think like the most helpful thing they did was probably they got a panel of like current and former master's students, just four of them, and they just gave us an hour of time, and they actually like left the room, so we got to do like question and answer just among students, which I think was like a cool thing. But yeah, and then we got pizza at the end of it, which was nice. But there's actually oh, you know what, it's also surprising, it was like 50-50 men and women, which is a nice surprise. I definitely like wasn't expecting that. And there's a lot of interest in mathematical biology, which was good to see. It's not a grad student without pizza. It's not. You know how these things go, Zach. I'll take free pizza though. Well, it's not. Well, if you consider it as part of tuition, it's very expensive pizza. But if you forget about tuition, it's free pizza. Yeah, I hope you're doing well. But since you had was at UCLA campus, really? I don't remember you talking about having attended there. Did you like pay for it yourself, or did you actually go there and I just didn't know that? You went for a quiz bowl tournament. Oh, okay. Wait, so did you travel just for that? Oh, that's cool. I love that. Traveling for you didn't really I'm sure the experience is still worth it. Yeah, you got pizza. And you got to travel. Oh, I chose the worst time of day to start my stream. I chose the time of day when the sun shines through the tiny gaps in my blinds right in my eyes. Ugh, I'm still not used to this happening. And I could also just fix it without too much issue, but I keep not fixing it. Um, yeah, I want to get some of these fundamental matrices just by hand, just to do the computation, because it's been a long time. And I'm still trying to work out how we're gonna find. So I understand what psi is. That's just basically your homogeneous solution put into a matrix. But then I want to understand how we would actually get phi, because presumably we're just going to do something to side to get phi. Oh, I guess if I compare equation 10 to equation 14, we're just taking psi and multiplying it by its inverse evaluated at the initial condition. Okay. E to the P inverse AP is your friend. Thinks about Wednesday stream. What was I doing on Wednesday? Well, that was probably the first day I was working on the Schrodinger equation. Oh, wait, you're good. Oh. Really? So I've been introduced to the idea of a matrix exponential, in that I know they have some connection with systems of equations. I don't remember exactly how though. And I know there's a 3 blue 1 brown video on it. I should probably just watch that, to be honest. Hey, Art. Oh, really? This was just the one that this is the more recent edition of the one that I use in undergrad. I didn't choose it for. Yeah, it is. That's kind of the only reason why I chose this book. It's just the one that I knew offhand. Oh, really? Yeah, I mean, for this specific thing, fair. My classes, like, this was the book that was written down that we were following, but we never actually used it in class, so I haven't really read it much. Oh, they say this exact thing right here that I worked out on my own. Okay. You have a Calc 2 test tomorrow, no matter how many integrals I solve, I just don't feel ready. Yeah, that's that's Calc for you. I mean, that's a lot of classes, but if you've been studying, I'm sure you'll do well. Yeah, that's very normal with Calc. Hey, Star. Grandmaster G? Are these chess players who are going for walks? And I assume the question is, where does he end at? Yeah, we can do this. Determine the displacement for the whole. Oh, displacement. Okay, that's an important distinction. Thank you for saying that. Okay, so let's draw what's happening here. Wait. I forgot. Oh. You have a middle part in there. Sorry. Thank you. Oh God, someone's okay. So someone's car alarm was going off. Thankfully, they got to it quickly. So, actually, I don't like those. We start going northwest. We then go west. We then go southwest. Okay. person really loves going west and not coming back to where they started. But I guess if there wouldn't be much displacement if they came back to where they started. So, okay, so for the first leg of the journey, north 30 degrees west. Let me label my thingies. So the first leg, we're going 6 kilometers an hour for 15 minutes. So we go 6 over 4 is 3 over 2. Sorry, I should do that in a bit more detail. We have 6 kilometers per hour times 15 minutes. We need to get the time units to cancel those. So let's multiply in a conversion factor. We know there are 60, in 1 hour, there is 60 minutes. And you saw almost, I was about to write it the other way, but I flipped it because there's minutes up top there, so I want minutes to be on the bottom here. There's hour on the bottom here, I want hour to be on top here. Because all these units are going to cancel out now. So it comes out to be, and I'm only going to do this unit conversion once, just to show you how it works, but this might not be the part that you're even asking about. So then we get 6 kilometers times 1 over 4, because 15 over 60 is 1/4. Then 6 over 4 is 3 over 2 km. So the first leg of the journey, we go 3 over 2 or 1.5 kilometers north 30 degrees west. Hey, syntax. Every 60 minutes an hour passes in Finland. Only together can we stop this. Very true. So for the second leg of the journey, we're jogging. Hey, Sage. Straight west. 9.5 kilometers an hour for 30 minutes. Converting that and doing the monster math. That's 4.75 kilometers. I'm not going to write in the units. It's going to take up too much room. I don't like mixing decimals and fractions, so I'm going to convert that to a fraction. Okay, and then for the last leg of the journey, we go west 20 degrees south. So we can kind of draw a mini northeast west south thing here and measure it from there. So start west, but then go down by 20 degrees. So something like that-ish. $1.75 for 20 minutes. I need a calculator for that. That's 1.75 divided by 3. Oh my god. Stupid Wolfram. Stupid Wolfram. Work. That's a stupid number. Okay. 583. Now I want to put things back into fractions. I'm swapping back and forth, and I shouldn't be doing this, but 7 over 12. Wait, yeah. What was 9.5 over 2? I'm going to make Wolfram Alpha convert that for me. $19 over 4. This is math, not physics. We don't approximate things. Okay. So, importantly, they're asking for displacement. Displacement is the distance from your original starting point to your end point. So the question is actually asking for this distance here. And we just need to use geometry to get that. Let me draw that a bit neater. I did draw this a little deceivingly. I'm kind of regretting that that light blue line looks tilted. It should be straight across like that. It's straight west. Okay, so how can we... How do we want to go about doing this? I guess we can think about vectors. Yeah. So you're saying that that's what we, okay, good. Because I think that's the easiest way of doing this. So the reason vectors are a good idea here is because if you take two vectors, A and B, and add them together, what you're really doing is you're putting the two vectors tip to tail. So something like that. And like this vector right here is A plus B. And so that's exactly what we have here. We just have three of them. And so we can add, if we can figure out how to represent all three of these things as vectors, we can just add them all up, and that's what we want. So we'll start off with the first leg of the journey. We know the magnitude is 3/2. So I'm just going to say 1 for the for like the first part. We know it's going to be 3/2, and then I'm going to multiply it. The x component is going to be cosine of 30 degrees. Negative cosine of 30 degrees. The y component is going to be sine of 30 degrees. And I worked that out because I looked at this 30-degree angle here, and I made a right triangle. And so I noticed that the horizontal part goes with cosine of that 30. And, oh, I got that backwards. I'm sorry. I got these backwards. Sine and cosine. My bad. I'm so used to x being with cosine that my brain just put it like that. But here things are reversed. The angle across from 30, or the angle opposite from 30, is our x direction. But we need to remember that it's going to the left, so we need to stick a negative sign in front of it. And then cosine is the side close, or like vertical, so that's our y component. So that's how we decided it on that. This is, whenever you just have like a sine and a cosine like this, it's a vector of length 1. And so I'm multiplying it by 3/2 to scale it. So what we can do is compute these two values and multiply the 3/2 in. So sine of 30 degrees, it's definitely something. It's 1/2. Cosine of 30 is root 3/2. And now I can multiply the 3/2 into each component. So minus 3/4. Then we get 3 root 3/4. Okay, that's vector number 1. Vector number 2 will be a lot easier because we're going straight west. We don't have to worry about components here because all it is just, we said 19 over 4 to the left, so it'll be negative 19 over 4 in 0. No further math needed there. And now for the third component, we'll do the same thing. So we know the length is 7 over 12. Then we look at the 20-degree angle and we make a right triangle. So the horizontal component this time does go with cosine. And we need to remember it's still going to the left. So we need to stick a negative sign in front of the x component. Cosine 20 degrees. And then it's also going down. So we need to stick a negative sign in front of the y. That'll be sine of 20. And that's work for a calculator, I guess. So I guess decimals are unavoidable here. What's your vector, Victor? Hey, Dr. L. Oh, what a stupid number that is. What the hell? -1 to the 8 over 9 times 1 plus -1 to the 2 over 9. Who derived that for the first time? I want to know. That representation for cosine of 20 degrees. I'm not using that. I'm going to use 0.9, I guess 94. Oh, we need a 7 over 12. W Green IHR Corp. Thank you for the follow. I need to multiply the 7 over 12 then. Let's go 3 decimals, I guess. 548. And then we'll do the same thing with sine. Uh, 0.200. Okay. And now we just do 1 plus 2 plus 3. But it's not 6. 1 plus 2. And really, my notation here is a little bit weird. With using 1, 2, and 3 like this. It just kind of came naturally to me, but a much more common thing would be to call the first one like A, the next one B, the next one C, and put the arrows above it. At the end of the day, they're just names, though. So, I mean, really, this is going to be work for a calculator, but we're going to take all the x components and add them up. And this is not the final step, actually, now that I think about it. Now we're going to take all the y components and add them up. Okay, 3 over 4, 19 over 4, minus 3 over 4, minus 19, minus 0.548. 6048. The y component, 3 over 4. 3 square root 3 over 4 minus 0.2. 1.099. Ooh, wait, positive or negative? Positive. All right, Um, my buddy was in flight school and for the Air Force, the instructor asked what is a vector. My buddy answered as an element of a vector space. Oh, that's hilarious. The way like a mathematician or physicist would heckle a flight class. Okay, so the question was for displacement. So we nearly have the exact thing that we want. The final step is to get the magnitude of this vector, because that's what the displacement is. That's what the length of this vector is. That's also displacement. So we're gonna say that the displacement is square root minus 6.048 squared plus 1.099 squared. And that's more work for a calculator. Hey, famished. Ah. 6.048 squared plus 1.099 squared. 6.15 kilometers. Got to stick those units on at the end. If you're doing some programming, nice. I was just doing that on Saturday. Not doing that well at it. CS star, I hope that makes sense. Let me know. Pseudocode, I'm translating the code into Java. Oh, good. Probably not a bad way to learn syntax. CS star, let me know if you have any questions. If not, I'm going to go back to my studying stuff. You think that displacement is a vector? Ooh. It definitely... Ooh. There is a displacement vector. I have a feeling they just mean displacement in the... in like, I guess, I have a feeling that when you first introduce a displacement, it's a one-dimensional thing. And maybe the further you go in physics, the more likely it is to become a vector. Star, the answer was 6.15 kilometers. Wait, how is it possible for... Oh, I guess if they start from different places... Oh yeah, okay, that makes sense. I think this is a more advanced physics thing when you start considering it to be a vector. What did you get for your 3 vectors? Oh, you're good? Okay, Star. Look, with the remote job I'm hoping to do the assessment they have me do is in pseudocode. Oh, okay. That's kind of interesting. All right, so let's solve this system of equations. Let's get the eigenvalues. Oh, you know what? I'm getting distracted. I want to Google something. I was kind of preoccupied during the orientation this morning by the idea that there might be... It feels like there's a similarity between evaluating integrals with residues and divergence. It just feels so similar. Divergence of like a vector field. Is it actually called the residue theorem? Wait, sorry for the black screen. I didn't realize that would actually become a black screen. I meant to look this up right after, and I kind of didn't. Cauchy residue theorem? Okay, yeah. So the thing I searched is good enough. What is the integral from 0 to infinity of x to the 69 e to the minus x dx? Is that like a hidden gamma function? Gamma function might be from minus infinity to infinity. Oh, is it the partial gamma function? Oh, hey. So this is gamma of 68, right? Or wait. Yes. No. Gamma of 70. And gamma of 70, that's going to be 69 factorial, right? Yeah. $69 factorial. There we go. And if that doesn't convince you, then let's do integration by parts and just make a DI table. We're only going to need 69 rows. Basically a synonym of Don factorial. Yep, you know it. You can think of the complex pole from 1 over z as a delta function in the associated vector field's divergence. This is kind of sick. I'm kind of... So, I didn't read through this entire post. But it seems like this person is saying you can go from one idea to the other. And I feel happy that I noticed that on my own. Well, I mean, I've definitely seen that there's a relationship between a complex function being analytic and that having a meaning in vector calculus with zero curl question mark. Okay, that answers that question. Obi, thank you so much for the raid. Welcome in, people. How's your stream, Obi? I looked in you a bit before I got on. Saw you're doing your continuing your series of streams on education. Hope it was good. You finally got your 5,000 points. That is a great one. Show and tell. Oh, I don't know. I put that on pause a long time ago. I don't know if I unpaused it. Oh no, it's not paused. I might need to pause it, to be honest, but show and tell is I just find something interesting and I show it on stream when I talk about it. I don't know what I would do it with, though. Just like some object that I have around my room. Yapper Lazen? What? Yeah, so for anyone joining from Obi stream, I was just working on this system of equations question, but it is suddenly art time. I need to, okay, new page. No, not right click. I go up here, paper color. Oh yeah, and then I need to choose from one of 20 shades of white. That shade? That's okay, yeah, that's fine. I hope that work went well for you, FA. Okay, so in repo, I'm normally that dark green, and then you're normally yellow. I'm trying to give of what perspective we should have here. I guess I'm gonna try and keep it simple and just do it from the side. You know what? I feel like I want to make this poop brown. And then I think it's gonna be way too hard to draw a full-on chessboard. And if I'm looking at it from the side, huh. This looks more like a queen. The kings normally have like little round. Wait, do they? I think the kings don't have the round piece, so that might be a queen thing still. Okay, and then I guess instead of white, I'll have to use gray for the white pieces. You'll be moving your horsey towards me. Oh god, why did I choose to draw a knight? No, their mouth isn't normally open. Me taking notes actually to beat you. This looks more like Snoopy. I'm sticking with it though. Okay, so I'm dark green. How do they... So weird to end a stream? Oh no, what happened? Well, in case you couldn't hear me before, thank you for the raid, Obi. I appreciate it. I hope your stream went well. Oh my god. Appropriately, I was just working on some differential equations just before this, which I am going to get back to after this. Internet dumped entirely? Oh no. Then mobile send everyone here. Oh wow. That's clutch. I appreciate it. Oh man, we said like googly eyes, I guess, in repo. Skirtle. You got here just in time. Yeah, the artist is here to judge. Should wait. Should it be like the anime tiers where they're like going like that? Do we? Oh wait, shoot. I didn't draw a mouth. I forgot. The mouths in the game are so funny. We can't forget about those. Cause they just like there's like on a hinge. Like that. Okay. There even be like a pool of tiers here. Okay, and then we need yellow. Oh, but yellows in this program are really crappy. How does that look? That's not terrible. Okay, so FA needs to look smug. You don't think they have blue tiers? Would they cry oil or something? I don't know. How do you make a robot look smug? Huh. How do you make anyone look smug? With eyebrows. Yeah. So wait, they should go like that? No, she looks worried. Now she looks angry. I don't know what those are. Raised eyebrows, right? I don't know. It doesn't look very good. Wait, no, raised and... Go up, slanted from the nose going up. Hmm. There's a lot of varieties. Oh my god, that's a crazy face. Hmm. I feel like these eyebrows are going at every which way in these images. Like maybe something like that. What did that look like again? No, that looks terrible. The smug guy spiffing. Oh, really? I don't know. It's hard to put emotions on a robot. There's a lot of stock images. Oh, okay, okay. I don't know. How do you feel about this, FA? This might be the best that I got here. Love it? Great. I post all these in my Discord. So let me get a quick screenshot of this. Just because, you know, these obviously need to be kept for the future. You'll frame it? Yeah. You should. Refrigerator. Yeah. We're really proud of you. We're going to put this up on the fridge so everyone can see it. Thank you for the redeem. I hope, Skirtle, you don't feel too nervous that, you know, you're going to go out of business now. Again. -1? If you get too many commissions, you're passing them to me. I forgot how much of a pain in the ass these problems are. Why do I copy the problem down when it's right there? Alright, so if lambda equals 3, -2, 1, 4, -2. We can really just look at that one equation. Ugh, worst Greek letter. If x equals 1, y equals 2. Yeah. -2, 1, 4, -2. Nope, positive 2. Wait, am I drawing my Kasai backwards? I think this is forwards. I honestly can't remember now. Greek letters. Okay. It's forwards. We're good. Oh, hey, you know what, Skirtle? I want to show you a clip of what FA did the other day. I'm calling you out, FA. We get shot. Oh my god. That makes me laugh every time. You get shot at and it's like, oh, he has a cooking pot. You just start sidestepping a little bit. Oh my god. No regrets, yeah. It's for a cooking pot. True. They are important. A full setup. You do the same even on Deadfall before the passage. Oh my god. See what was inside. You can't see what's inside it if you're dead. I apparently Skirtle just agrees though. I'm outnumbered here. Okay, so I would normally write the solution to this system like this. So if you like you and Jake die of hunger on the other side while me and FA have noms. No. This is why people like me and Jake are like splayed out dead. Okay, so then our fundamental matrix psi is e to the 3t, 2e to the 3t, e to the minus t, e to the minus 2t. Does the order matter? It might actually matter for this. Wait, why did I say e to the minus 2t? It's minus 2e to the minus t. Got a little case of skill issue. I haven't been to their side either. Me and my friend Malcolm were trying it for, well, I guess we only did it for 2 sessions and we didn't even get close, but it was a lot of fun for those 2 sessions because I don't know math. That's why. True. Be the Sherpa. Well, that's lame, Skirtle. That's where it gets exciting. Yeah, I'm just wondering because like I found psi, but the way the book is doing it, phi is the one where well, I guess they say it right there, and so I don't know if I'm gonna get like some permutation of the identity instead if the order is wrong. Can we Sherpa skirt again and do that shit for a whole month? Have you have actually been to the other side yourself though, right? So wait, how do we actually find it? We take the thing we just found, multiply it by the inverse evaluated at t naught. So let's evaluate at t naught first, because that'll be the easy bit. You made the mistake of going through the door. I want to do the whole quest one day. Oh man, I'm gonna want to try this both. If you wait, how would you invert a matrix of functions? Surely that's still possible. You'll be willing to Sherpa my group in a year. You're staying away from Daisy. Gotta take a break sometimes. I'm gonna get completely sidetracked. I want to try to invert that with functions now. Oh, can you do the same thing? Okay. Let's try it the smart way and then try it the dumb way. So AD minus BC, -2 minus 2 is -1 or -4. Same thing. Oh, I forgot to show this on stream. I got this like weeks ago, but I went to the bookstore for my school and they gave me a whole bunch of stickers and some of them are really freaking cute. I don't know, like I have a bottle or like a bottle and a travel coffee mug I could put them on, but then they're gonna get wet if I wash them. Benblocks, hey, how's it going? But yeah, so actually, so first off, you know, a husky is the mascot, so these all have huskies. So these ones are both pretty cute. The present one I think is better because this one it looks that's kind of a cat-like dog, you know. But then these other two are awesome. I think this one is my favorite, and an employee like pointed out it was like his favorite too. But I like these both. The camera's not quite in focus, is it? I don't know. That's good enough, right? But yeah, I know. I thought that they were cute. This one I would never put on anything ever. I don't know if I'm a fan of this one. But yeah, I don't know. Those have been sitting on my desk for a minute. I might just like show them on stream. I just had an orientation today. The actual first classes are on Wednesday. It's too very put on your bathroom mirror so you can look at it while you brush. True. How do you invert 2x2? Swap these two, negate those two. I hope I'm doing that right. First class is hype. Yeah. I'm more nervous than hyped, but everybody calm the funk. The funk? Calm the fuck down, it's happening. Oh my god, dude. It was really bad. For the entire orientation, I was not thinking about my age, which I'm 28. But at the very end, we had pizza, and we're just like often like little groups having conversations. And so my age came up, and someone asked me, "What does it feel hanging out with all the youngins?" Because they had all just graduated, and I was like, "Oh man, I'm the old guy now," and I'm only gonna be like 6 years older than your average like college grad at 22, but I'm the old man now. Yeah, Finbox, I'll have to stream like me doing tests, so I can just have you guys sit in my pocket. You guys can solve the problems for me. No, 20 is young for a master's there, really? That's crazy. The most common thing is to do a master's right when you're done with university. So you'd finish a master's at like you graduate university at like 22, and then you would get your master's at 24. Master's at 27-ish. Ooh. You milk more money if you have forcing into a master's. Oh, that's a lot of school. If you're in school constantly, or is it more common to like get a job and then come back for a master's? Okay, your full degree without the need of a master's. Okay, that's here for people who don't know what to do with their lives. Well, it's serving that purpose for me too, so it's okay. Well, besides math streamer, I guess. Wait, but a doctorate doesn't mean you're well. The way you say that makes me think of like a medical doctor's skirtle, but yeah, I guess so. Strict stereotypes only. Dumb feed. About to finish my undergrad in the winter. Want to go for a master's, but can't really justify that taking on more debt. Look, I'm gonna pay for it eventually. That's fair. Your name sounds so familiar. I can't quite put my thumb on where I've seen you before. That's not a first time chat. I don't know. Sorry for just my bad brain, but congrats on almost finishing your undergrad. I felt the same way about a master's. I forgot to turn my light on. There is such a thing as a funded master's. I didn't get accepted for funding here, but a bunch of other people I just met today are funded just for a master's. It's pretty rare. But what you can also do, if your application is strong enough, apply for a PhD, get accepted. That's the part where your application needs to be strong enough. And then in pretty much every PhD program that I've seen, you have the option of getting a master's 2 years in as you continue on with the program. But you could just get the master's and then drop out if you wanted. And then almost every PhD is funded. So that's a thing that's also like possible. Oh, okay. Fair enough. Hey, I appreciate a lurker. Okay. Close enough to type of deal? Fair enough. Yeah. So matrix multiplication, that column times that row and add them up. That column times that row. That times that. Wait, you call me who paid law school fees, then withdrew one day before classes start? Oh no. Well, do you not get a refund? At least here, you get a refund, like, you at least get a partial refund. It depends how late in the semester or quarter you are, but like there'll be a certain like date where you get a full refund and then like a 3/4 refund and then half refund and so on, depending on how late you drop it. So let's check if our answer is right by checking what phi of 0 is, because that should be the identity. 1, 0, 0. Oh, hey. Well, now I want to try the other thing, which is inverting this and then plugging in 0. I have a hard time justifying it. I assume you can do it in either order. I don't know why. I feel like the order should matter. So that times that. You add the exponents. Oh no. It doesn't have a general inverse? What? That can't be right. Oh wait, no, I'm stupid. They're both negative. I thought one was positive, one was negative. Switch the main diagonal. Negate the off diagonal. This is a stupid inverse. But if I plug in 0, do I get this? It's my main question. Why did I say 1/2? 0. You do? Wow. That's wild. Okay. Oh wait, they talk about the matrix exponential right here. Okay, so the nice thing about the matrix exponential is that it solves a system of differential equations in the exact same way a regular exponential solves a single differential equation. Hey, Najaf. Include that exp of a of t and the fundamental matrix phi of t are the same. Aha. I was kind of just doing some circuits and then an electrostatics problem. Ooh, nice. Even after all this time after doing that reading group, I still really want to study more E and M. It turned out to be way more interesting than I thought it would be. Putting the electric field above the center of a uniformly charged disk. Oh, nice. Yeah, you can Gauss's law that, right? You can just draw a small, like, pillbox. They are fun, yeah. Oh god, Najaf, I'm sorry. I'm terrible with AP and GP problems. I don't think I can do that. No Gauss's law, though. We did a double integral. Ooh. Probably a lot harder. I'm pretty sure you can do it. With Gauss's law. This is a terrible disk. How do you properly draw a disk? That's still bad. Maybe it is only for an infinite sheet. Or maybe Gauss's law is only approximate. Like, really close. Oh, yeah, you know, I guess Coulomb's law... Yeah, I think Gauss's law would only be valid very close to the disk. Okay, yeah. That makes sense now. Gauss's law, there's no way that would work if you're far away. Yeah. I think it was so much fun, even though Purcell more and more brutally. It makes you think, because there's even the Jackson book that's supposed to be the real difficult book. It makes you wonder how hard that book could be. I'm sure it's brutal, but it's like, man, if Purcell and Morin was that hard, then I can't imagine what kind of questions that one is even asking. Yeah, so I've been helping out Mouse with some problems in DMs. He's been using Griffiths and then an engineering text. Or like his classes, the class he's in is using an electrical engineering book, but he's also using Griffiths to learn the actual physics and not just the the engineering. See, you showed me the book, and actually, I want to show it because I thought it was kind of funny. Just the difference between physics and engineering. So yeah, this is... why are there dancers on this? What E&M is this? I don't know. Because I just like skimmed it. And so, you know, you have some history, you have some math introduction, some more math, and then bam, the first real physics you do, you just get Maxwell's equations. That's the very like first thing. Whereas we had to work for like 9 months to get this full set of equations. They just start with that basically. Why is... Oh. I'm trying to figure out why they're using D here instead of E. But it makes sense if you're gonna not be using the vacuum of space. I'm a little bit curious for why this one you do just use E though. Yeah, like especially for engineering, like this is the right thing to do. It's actually a super deep physical reason for that difference in the laws. Really? Well, now I want to Google that. Because of relativity. Oh, man. Okay. Why do some of Maxwell's equations depend on the material, I guess? I don't know if it's probably a better way of Googling this. Maybe Wikipedia would give me the term that I need. No, linear algebra... I don't think there was a linear algebra class that's really being offered. There's a numerical linear algebra class I could have taken this quarter. I chose to do scientific computing instead. But there's not a standalone linear algebra class, I don't think, in my department. Just numerical. So actually this difference led Einstein to special relativity initially, more specifically the Lorentz symmetry of Maxwell's equations. So yeah, I knew he found special relativity and wrote his initial paper on it in the context of E&M. And I learned my first bit of special relativity from an E&M book. Be in this one, maybe? Whoa, what's... Oh, okay, this is showing how electromagnetic waves work. Quick math question. Does every Hodge class come from an algebraic cycle over a smooth projective variety? Yes. Definitely. Anyone who says no clearly doesn't know what they're talking about. That's a oh really? It's a it's a millennium problem. Someone pay me. I only know about the Navier-Stokes equation. That oh wait, and the Riemann zeta, or the Riemann hypothesis. Why am I getting all these random text messages today? This doesn't tell me the exact thing that I wanted. Thank you for the link. Hey Jermaine, hope you're doing well. Can write them with tensors. Oh god. I'm getting PTSD from these superscripts. Oh no, you can't have 4 of these. Oh my god. Do Maxwell's equations matter? Not if they're in a vacuum. Well, actually, they still matter a lot there, I guess. I assume you're making a joke about matter. I'm not quickly seeing. Well, I guess the question was why some of the equations depend on the material and some don't. If the answer to that is in this section here, I don't see it immediately. But it's not the end of the world. I'm not even quite sure how to like phrase that into Google anyway. Yeah, I don't know. I feel like I've been here. I've been streaming on the same schedule, but I'm still streaming. Gauss somehow has a share in all of these laws. Gauss. It took me a little too long to realize that the Gauss of Gauss's laws, the Gauss that also did math, because like, how the hell does one dude do so much different stuff? Yeah, I did a YouTube stream on Saturday, and then I did one more earlier in the week. But it has been slowing down a bit because I've been busy with some life stuff. Saminadu? Number theory. Actually, wait, how many mathematician, astronomer, geodesist, and physicist? Geodesist? I didn't realize you could be a geodesist. Taking Calc 1. Oh, nice. We're just kind of chatting about random shit right now, I guess. We were just talking about Gauss's law in physics. And then I was doing some differential equations studying, which is kind of like the thing you would do right after your first like 1 or 2 calculus classes. You found Gardner Mansion again? Oh, really? Like the same dude? Or a different mansion? Same dude, you report his base again for fun. I saw on the Discord you guys were gonna do a new scenario. Have you not like switched yet? Oh, I mean, I've gotten a little bit bored of at least the thing that we're on right now. I don't know if I would really switch because I don't know if it'll be that much more exciting, but a lunar reveille event, we get a doo-doo bucket hat? Okay, no, that sounds interesting. A new map, wave winter. And for me, it's just like it feels like grinding just so I can do more grinding, which I know is kind of the point of an MMO, but I don't know. Sparky wants winter. I'm done with the weirdos in our server. um, maybe it'd be worth a try, but um, I don't know if I go like hard in it. It's like I don't know. It just like all I was doing was just trying to get like the perfect mods or the perfect like calibration and stuff that wasn't like super interesting to me, I guess. Doing the same like bosses and stuff over and over again. Pal World scenario, you have team of 3 apparently merged them together. Oh yeah, you were talking about that. It's kind of weird. Merge them together. Hey, Asman, do you have a question? You can ask it. I always forget how this works. Finding eigenvectors with repeated eigenvalues. I think you find the first one normally, and then you find the second one by setting the equation equal to the first eigenvector. Okay. I would say that makes sense. I don't know why that's true, but that does match up with what I remember, Obi. Yeah, I guess that's the equation right there. Specific source I use for studying math. Yeah, I mean, a harder one would probably be better, Skirtle, for me at least. So the website I'm looking at right here is fantastic for calculus, in my opinion, Jermaine. And if you just want to learn like the intuition of math without getting too deep into the weeds of calculations, 3 Blue 1 Brown has a series on calculus. He's on YouTube. Has a series on calculus that's really good and very like visual. So those are probably like the top like 2 things. Exponential rules. Just like rules for exponents, like like, are you asking about like these? Asman? So the new one needs to map to the null space and be linearly independent of the first. Oh my god. Why are you in my face? How do I make it so it's not my face? What did I just click on? Okay, I don't know what I did there. Yes? Okay. Why are they're just kind of repeating that? So I guess I can tell you, like, I can give examples of all of these rules here. But if you're really asking about like something else, or you have an example of a problem that's giving you trouble, let me know. Sounds good, Jermaine. No worries. Do examples for the bottom 6. Okay. 1, 2, 3, 4, 5, 6. Okay. So yeah, these first 2 are how you handle what's called like the same base. So if I have, for the first one, 2 cubed times 2 to the 4th. They had the same base because they're both 2s on the bottom, and that's important. So when they have the same base, the exponents add is the rule. So 2 to the 3 times 2 to the 4 is the same thing as 2 to the 3 plus 4. And so that's 2 to the 7. And I just happen to know that that's 128. And the reason that this is true is because I could always take this original equation, and I could remember that 2 cubed is just 2 3 times multiplied. So that's 2 cubed. And then times 2 to the 4th is just 2 multiplied 4 times. But look, we just have 7 2s all multiplied, so it's just 2 to the 7th. So like that's why the rule is true. You can always expand everything out. And we can make a similar argument here with the next rule, which is the same base but division. So let's do 2 to the 6. Actually, no, let's use new numbers. Let's say we have 5 to the 5th, 5 to the 6th, divided by 5 to the 2. So here, I'll show it the long way. We can expand everything out again. 5 times 5 times 5 times 5 times 5, 6 times, divided by 5 times 5. But with division, this is all like multiplication here, so we're allowed to cancel things. So we have 2 5s on the bottom, can cancel with 2 5s on the top. So we just end up with 5 to the 4th. That one is 625, but this is just me showing off. And then the next rule is what you do with negative powers. Is there a good explanation for that one? Kinda. I don't know if I really like the thing that's going in my head right now, but basically, if you have a negative power, say 3 to the minus 5, you flip it and you make your power positive. So 3 to the minus 5 is the same thing as 1 over 3 to the 5th. Do I know 3 to the 5th mentally? I bet it's 281. I don't remember though, or it's something like that. 241, 243, 243. Yeah, with that one, I would just remember that one. I can't quickly think of a good like intuitive explanation for why that's true. The thing that does come to mind is well, no, I don't want to go there. Yeah, so that one, I don't have a better explanation for you than just remember that one. Oh, that's tricky, Cat Master. Yeah, okay. So Cat Master is pointing out kind of a neat way of thinking about negative powers, which is we could think about the addition rule that we already know from earlier. And if we have 3 to the minus 5 times 3 to the 5, by the addition rule, we know that's equal to 3 to the 0. But anything to the power of 0 is just 1. So what I could do is, so I guess let me rewrite this. So we end up with 3 to the negative 5 times 3 to the 5 is 1. And just using algebra, we can divide out the 3 to the 5 from each side. So it cancels there. So 3 to the minus 5 is equal to 1 over 3 to the 5. I like that. I was going to say, talk about how like 3 to the minus 1 is like, it looks like an inverse for multiplication, but I don't think that's a very helpful explanation. Okay, so next we have what to do with powers to a power. So if we have 4 squared in parentheses cubed, the rule is that we're going to multiply these powers, but let's find out why. So let's look at this outside cubed and remember and expand that out. So we have a cubed, whatever is inside the parentheses here, you have 3 copies of. So we have 4 squared times 4 squared times 4 squared. But now we can use our addition rule and realize we have 2 3 times. So 2 times 3 is 6. And so the shortcut is, just do 2 times 3. The next rule is if we have 2 different things in parentheses. So let's say we have, I guess we can still use some numbers. Let's say we have 3 times 5. I guess we can square it. Um, we and so like the pattern with law is that we can just kind of expand them out, except for the inverse one, I guess. But if we expand this one out, we get 3 times 5 times 3 times 5. So just 2 copies of 3 times 5. And then we can rearrange this to be 3 times 3 times 5 times 5. So that's just 3 squared, and that's just 5 squared. So the moral of the story, if you have two things multiplied to a power, you can just make it so each thing gets their own power. Then finally, our last property is this a similar situation, but with division. So let's, I'm going to choose 6, and I'm going to divide it by, it's not, let's choose 7. Divided by 4, and we'll cube it. Just like with multiplication, what we're going to end up with is each number gets its own power. But the reason why, again, goes to expanding it out. 7 over 4, oops, times 7 over 4, times 7 over 4. We can multiply across the top, multiply across the bottom, make it one big fraction. And then on top, we just have 7 cubed, and on the bottom, we have 4 cubed. So yeah, that's how I think about all of those rules. I of course I wouldn't do this every time I'm expanding. Like I don't expand these out every time I work with exponents, but this is a good thing to see when you're first learning these rules. So you know they don't just come from nothing. There is a reason why they exist. And it kind of just goes back to the definition of what an exponent is. That's what you can rely on the most. No worries, Asman. Thank you for the question. Okay, so I think where I guess I was yapping before this, right? Oh yeah, I was thinking about repeated eigenvectors, eigenvalues. You too, Asman. You really need to draw on the eigenvectors when you do this. I guess I can see the eigenvector is going that way. It's like -1, 1. But that's not gonna be obvious to a student learning this for the first time. You gained energy points in chat? What? YouTube does have that like top fans thing. I don't get how they calculate it, but maybe that's what they mean. Oh my god, there's actually look at this. People have XP. That's so weird. I'm a level 5 chatter. That's so weird. Use XP, but you have like a leaderboard like that, I guess. I don't know. My T wants to be Twitch so bad. Apparently. I think that they both want to be TikTok, to be honest. And they're just like doing anything to farm engagement. Hey Slim. Yeah, this is like a the linear algebra section of a Diffie-Hughes book. So this is like the Diffie-Hughes book that a bunch of like schools use. I was just kind of reviewing systems of differential equations. Not because I'm not going to need them immediately, I don't think, but this is like one of the last things I was doing for my undergrad degree, and I just kind of want to remember a bit more about how they work. Hope you're doing well, Slim. But well, I might need them for the biology class I'm doing, computational models in biology, whatever it's called. Beauty companies will do anything but go to therapy. Yeah. What about non-homogeneous? Yeah, I think that the complex analysis class is going to have a little sprinkling of Diffie-Hughes, but I don't think they're gonna touch systems. God, every time I try to read this textbook, it goes in one eye and out the other eye. I don't know if that's a real expression, but it's just so dense. Let's just read through the example that they're doing. So naturally, you start by finding the homogeneous solution, and that makes sense. Anna of Swift, thank you for the follow. Hmm. I think I should find a different differential equations textbook. This textbook, every time I read it, just kind of makes me not like differential equations. I'm not giving it much of a fair chance by just skipping straight to an example problem and not reading their introduction, but this is the Boyson de Prima book. I just kind of pulled it because it's the one that I used in undergrad. Well, like it's the one we sort of use in undergrad. But really, like the professors took what they needed out of the book and taught it their own way, and I never really had to read the actual book. Trinity Trench. I'll have to give that one a look. Yeah, it is a really common one. I just haven't been liking it as I've been actually trying to like read it. Okay. I'll take an actual look for it another time, but or like, I'll keep it like tab open and look closer at it after the stream. I could just sneakily go back to doing complex analysis stuff. This feels more, this variation of parameters thing feels more like what I was doing when I was learning this. Ooh, you can Laplace transform a system of equations? That's interesting. Huh. And it kind of behaves the exact way that you would expect it to, it sounds like. All right, that's cool. Um, I don't know if I want to go back to trying to tackle Schrodinger's equation though. I could look for a different DVQ from the complex analysis book. Look for a Fourier transform problem. 5 is like my great white whale for Moby Dick. As far as I know, I've done part A correctly. They might be nice and provide a solution in the back of the book. They also might not be nice. Part B was looking kind of complicated, so I gave up on it temporarily. 6A could be cool. We could also look at the wave equation. But they want Laplace. I want to do Laplace. I think 6 is going to be a good one to do. Get back to the Fourier cosine. Hey, Kane. How's it going? Where does this book do the example? With, I don't remember, do they use Fourier sine or cosine in their example? Here we go. Sine. Yeah, it is. Thanks for asking. So we need to grab the Fourier cosine transform. Oh, do we have to figure out? Ugh. We need to figure out what the Fourier cosine transform of a derivative is. Okay, here's our cosine transforms. Wait, do they tell us it? I would love it if you told me it. Okay. You give me the first derivative. Ah! Similar results. You expect me to do the work myself? Disgusting. Oh, wait. Oh, no, yeah, we have second order, so we do need to do some work ourselves. Okay, first order of business. The Fourier cosine transform of a second derivative. All right, see you, Jermaine. Thank you for hanging out. Really? Catmaster? That would make perfect sense. Oh. Okay, I'm with the first derivative for sine and cosine, I do notice they have a different number of terms, which seems to agree. Wait. The Fourier sine. Wait. Oh no. Oh. I'm only just noticed that we had some cross pollination happening, and I guess there should be because of the thing a Catmaster is saying. The Fourier cosine transform formula results in a Fourier sine transform, and the Fourier sine results in a Fourier cosine. So wait, what? Okay. So what I want to do is reconstruct the result for the first derivative using these two formula on the screen right now. Just make sure that I understand what I would actually do here, and then just use that trick that you say for the second derivative. So this is the sine and cosine. I don't know where to put it yet. This is the general. So ooh. No, this isn't quite what I thought it would be. Why does that look so scary? It is kind of scary art. I don't have a better explanation for you other than it is scary. So another maybe more intuitive explanation for that in terms of integration by parts, you're essentially pulling a derivative of f(x) under the integral, pushing it onto the kernel for sine slash cosine that causes them to mix. That's interesting. I don't fully understand it because I guess like kernel is going to be like the null space of the like I only know of kernel as like a null space of like a linear transformation, and that's probably the exact same thing here. And I guess that's what this step is with when the null space gets involved with these like limits or the kernel, I assume. Yeah, hello Jenny. This is from an applied complex analysis book, and the thing I'm currently trying to do is solving the heat equation with Fourier cosine transforms. Self-notation, the kernel means... Oh, okay. I haven't heard it. Okay, I didn't know there was another kernel, to be honest. I just know the word kernel does get used in a lot more contexts than I'm familiar with, but still in the linear algebra sense. So I just kind of assumed it was that, but I guess not. Because I don't know where you go to get it, but like I would love to learn linear algebra on things that aren't just like the regular vectors of numbers. But I think you have to go into specific subjects to learn that piece. But then they don't do the linear algebra part justice. I guess I should just look for more advanced linear algebra book someday, but... Okay, I guess this isn't... I think I'm just going to go the integration by parts way. What I was going to do is take the cosine, do plus I times the sine transform, and hope that matches up with that. But it kind of doesn't. There's an extra f of 0 I don't know what to do with. And these terms don't work out either, so I don't know. I think I'm probably going to play it safe here and just derive the formula the old-fashioned way. I'll pull these down for now, in case a thought occurs, but... So we're going to take the derivative of cosine kx, integrate f double prime. Fundamental theorem of calculus shout out. Okay, then this is just k times the Fourier sine transform of a derivative. So I could cite this formula here. Yeah. And then what happens with this one? I hate the way I made that parentheses. I hate that the singular version of parentheses is parentheses. F prime of infinity, what do we do with that? I assume we're going to call it 0. It has to be 0 probably for some reason. Otherwise it wouldn't be an L1 or L2 or whatever. But we do get an f prime 0. Is that okay? We shouldn't get that. Should we? Maybe we should. I want to verify this. I don't entirely trust this. I think I did it right. Hey, Loki. Yeah, so I would do a second integration by parts. I just noticed that the book had already done that integral for me, and I just cited the result. This is a really weird document. Like, what is this text? This feels like image recognition of text. Or like text. I said that backwards. Text recognition in an image. I'm willing to just roll with my result, but if I can easily find some verification of it, I wouldn't mind it. Okay, this looks like it. Okay, so I've gotten... Both those things are negative. Did I... Oh, yeah, I did drop a negative sign. I'm glad I checked then. I'm looking at this line right here. So, okay, that document was very sketchy, but I definitely forgot the negative sign here because that 0 was the lower bound. Okay, I'm willing to just roll with this. Delete. Okay, so we're gonna take the heat equation and take the Fourier cosine transform. Yeah, they are. So we're gonna end up with d phi hat dt, which is now a function of k and t. is equal to so we're taking the Fourier cosine transform in X. And the Fourier cosine transform of that from the thing we just found is minus k squared f hat c k minus f prime 0. I should verify that f prime 0 thing. Yeah, okay, the thing does have f prime 0. Oh my god, not f hat. It's now phi hat. I guess that's a C. This is now a linear first order differential equation. Ordinary. Non-homogeneous. You're just a constant. Integrating factors, I guess. I don't want to derive that. I just don't feel like it right now. I really should just derive this for the practice. Because this is never really stuck in my head in the way that I want it to. Hey, goated Almond, you can post them in homework help or math discussion. Either works. And if I don't see it, please type something in chat and ask me to check it, because I don't always see it immediately. Okay, so the integrating factor is e to the integral k squared, non-negative, dt e to the k squared t phi hat c of kt. It's 1 over the integrating factor times integral integrating factor times that. It's just a constant. Plus some constant with respect to t. So it could be a function of k. Let's see what pops out. Why don't I'm saying F. It's phi. Do we know what phi of 0 is? Wait. Isn't this it's an x, so it's phi of 0t? I should have been paying more attention to that. I think it's that. Oh, okay. I see you posted your question, Almond. 1, 2, 4, and 5. That's the integrating factor. Hello, Jenny. So the differential equation is in t, so k squared is a constant for our purposes. My notation is terrible. I need to figure out if we actually know what that is, though. B prime of 0t. Oh, it's g of t. Okay. Yeah, I need to do a little bit of fixing on that, but look at Almond's questions first. So there's these, and there's also these. Rounding to 2 decimal places, what is the form of the complex number 3 minus 6i when expressed in polar form? Are you allowed to use a calculator? I guess it doesn't matter. The angles are all the same. You don't need to do calculations for this, actually. I think, for number 1. Yeah, we can just graph this. Because we know 3 minus 6i, positive, real, negative, imaginary. Like, it's somewhere in the 4th quadrant. Like, it's somewhere, like, down there. 60 test quiz, 60 minutes? Wow, okay. So let's just check, like, which one of these are in quadrant 4. This one is negative, negative. Oh, wait. That's so stupid. I don't know this. It's cosine of 1.11. All math concepts, including calc. Wow. Okay, well, pi is 3.14. This is a little... Yeah, it's between pi over 3 and pi over 2, right? Yeah, okay, good. So... all of these cosines and sines will be positive numbers. That's the piece I mostly wanted to know. So we have a negative out front, which means these are both going to be negative numbers. So that's quadrant 3. That's right out. This one, positive x, negative y. That fits the bill. This is a candidate. This one is another negative, negative, because of the negative out front. So that's quadrant 3, that's out. This one is positive, negative, so it's another candidate. Okay, so we only have to decide between B and D. And the only difference is cosine is the order of the cosine and sine. So but Euler's formula. I guess we could just do that, yeah. But I mean, the issue is that I assume we're not... Maybe we can use a calculator, I don't know. So I wasn't actually drawing these. I drew where the point they gave us is to figure out what quadrant it's in. And then looking at the signs of each of these components, you can figure out what quadrant those are in. So like, that's how we can eliminate answers we know are bad. And so I think the answer is going to be B. Spoiler alert. Um, yeah, Fizzbuzz, that's basically what I did there. You know the angle is arctan minus 6/3, which is a negative angle. Yeah. Um, yeah, but I think yeah, Fizzbuzz has given the better version of the logic I was using, which just eyeballing 1.11, um if we know that pi over 2, you know, I'm just gonna say it's about 1.5. It's a little bit more, but 1.5 is good enough for our purpose. You're probably right. And then pi over 4 is kind of the important break point, and that's going to be, it's less than 1 because pi is 3 point something. So if you do 3 point something divided by 4, it's less than 1. And so we don't need to make like particularly good estimates here. I just want to figure out approximately where 1.11 is in radians. And what we've done is we figured out it's somewhere in this area here. I don't even care where it is. The important thing is that everywhere in this area, sine is greater than cosine. Like I'm still looking for the exact like words to express this. The y component, -6, is more than the, I guess I should say imaginary component, but same thing as y. That's like a bigger number in absolute value. It's like this I'm thinking about this in a visual way, and so I'm struggling to express it in words. But basically, we need to travel further downwards than we need to travel horizontally. And the same thing happens in this like quadrant here. This is a terrible explanation. Okay. The simpler explanation, by the thing we said before, sine of 1.1, because we know we're in this region here, sine of 1.11 is greater than cosine of 1.11. And we know that -6, well, at least 6 is more than 3. We don't have to care about sines. And so that's how we know the sine should go with the imaginary, the cosine should go with the real. These are like, yeah, I would call these like very tough high school level questions. In Kentucky, nice. So yeah, goated almond. It's basically the logic that Fizzbuzz put there in chat. I'm having trouble putting it exactly into words here, but it comes down to not caring about signs. We know that 6 is more than 3, and so we can figure out that sine of 1.11 is greater than cosine of 1.11. So yeah, I hope that at least makes some sort of sense, even though I'm explaining it terribly. I'm going to start looking at number 2, but feel free to ask me a question about 1. Jay Vance asks if you guys know. First question is quite simple. For you, it might be simple because J advanced is so crazy, but yeah. Sounds good. Goated. But yeah, like the first step is definitely like figure out what quadrant these are in, and then the only difference to figure out then is the cosine versus sine thing. So number 2, we have a 4th root x squared, a 3rd root y to the 5th, square root z to the 1/2, expressed using only reduced components. Well, I hope I don't get tricked here, but I think we can just use our regular exponent rules. So I definitely work from the inside out here. So I would start with the z to the 1/2 square rooted. A square root is like an exponent of 1/2. So if you have z to the 1/2, I could rewrite this as z to the 1/2 to the 1/2. And then a power to a power, you just multiply them. So z to the 1/4. So that's the first step I would make in simplifying this. And then now since we have multiplication, it's y to the something times z to the something. They can each get their own cube root, and we can use the same exponent rule. You know, let me just move the second image down, so I have a bit more room. So I'll write out this step here so that they can each have their own cube root. And then we'll use the same process that we just did here to get those into fractional powers. So it'll be y to the 5/3, z to the 1/12. And now we can repeat this process with giving them their own 4th roots. So we're going to get x to the 1/2, because 2 times 1/4. Then y to the 5/3 times 1/4. It's 5/12. Times z, to the 1/48. What a terrible number. And now we just have some fraction math to add up these exponents. So 1/2 plus 5/12 plus 1/48. 1/2 becomes 24/48. 5/12 becomes 20/48. Then the 1 stays as is. So what do we get? 45/48? Now we can simplify that. They have 3 in common. 15/16. Okay, good. That's answer A. So yeah, I hope that makes sense for 2. By the way, Goated, if you have more questions like these, there's a whole bunch of people who stream math on Twitch besides just me. It's like each of the 2iPi is another one who streams math help. Hold up. Okay, yeah, I'm holding. Yeah, if you're interested in getting like more math help and I'm not around. There's a whole bunch of people who do stuff like this. And there's another one in simplex pachinko. But yeah, feel free to let me know your question here. So basically the roots are seen as like 1 over n. Oh yeah. So sorry, I maybe assumed that you knew that and I shouldn't have. A root is the same thing as 1 over that power. So a square root is the same thing as a power of 1/2. A cube root is the same thing as a power of 1/3. And so on, like that. And so when you have a funky thing like the cube root of x squared, it's x squared in parentheses to the 1/3. And then there's an exponent rule to multiply them. So x to the 2/3. So yeah, that's where I was getting all those numbers from in the exponents. No worries. Oh, you're doing cross products? Wow. All right. We can do a cross product. Eliminate stuff based on J. Oh, that's true. Wait, ooh. Yeah, okay, but we still have to set up the matrix, right? Okay, so to do a cross product, I'm going to assume you know what to take a determinant, but if not, tell me and I'll back up. We set up, or actually, yeah, tell me if any of this makes sense to you. We set up a 3x3 matrix. The first row are the unit vectors for the coordinate axes. So this is the x component, the y component, the z component. Like that, but it's different for 3x3s. And the second row is your first vector a, 2, 5, minus 6. And then the third row is the next vector b, which is minus 4, a 0, importantly, because there's no j, and then a 1. So, yeah, what you said is the determinant for a 2x2 matrix, which is AD minus BC. For a 3x3, the process is a little bit different, but it does rely on this, actually. So the process for getting the determinant for a 3x3 matrix, and actually I'll just show you this because like Zach's found a way to like save some work here, but I think it's worth it to show you the thing in full here so you know how to do it. For cross products, you pretty much always want to do it in this way. For general 3x3 determinants, there's some more like flexibility. You basically choose one row to eliminate. So the thing that you should always do with cross products is eliminate that row. And we're gonna set up 3 different 3x3 or 2x2 matrices multiplied by each of these vectors that we eliminated along. So there'll be a 2x2 matrix with times I hat, and we'll fill this in a second, minus that sign is important, another 2 by 2 times j hat plus another 2 by 2 times k hat. So whatever row we eliminate along determines like the coefficients here. So the I goes there, the j goes there, the k goes there. Now to determine these 2 by 2 matrices, the one that goes with I, we're going to cross out the column that goes with I. And then this is what we're left over with is a matrix that we want for I. So 5, -6, 0, 1. It's very weird. There's a reason that this works. When I first learned it, it was better just to memorize it. Actually, to be honest, I still just have this memorized. I couldn't tell you exactly why this works. The signs, there's a very deep, or it's not like very deep, but you just need them. It's difficult to explain why you do need them. But just remember, it goes plus, minus, plus if you choose this first row to eliminate along, which you always should for a cross product. So, yeah, unfortunately, when it comes to like showing someone how to do 3 by 3 determinant, my best explanation is just remember it and deal with it. Matrix determinants are a pain in the ass, unfortunately, to learn why they are the way that they are. Yeah, there's a little bit more I could show you about with the signs, but I don't want to make a confusing thing even more confusing right now. But yeah, so that's how we figure out the 2 by 2 that goes with I. We cross out the column that goes with I, and then we take the remaining 2 by 2. So we can do the same thing now for J, take out that column, and then we get this for a 2 by 2. And then one more column to cross out for K. 2, 5, -4, 0. Okay, so now we have a bunch of 2 by 2 determinants to calculate, which you already know the formula for that, so I'll just kind of go through it quickly. So 5 times 1 is 5. Don't worry about the 0. Minus 2 times 1 is 2. Minus 24. 2 minus 24 is -22, but there's a minus sign out front, so we get plus 22. And then here that's 0, so we get minus -20, so plus 20. And that's our cross product. These have a whole interpretation and stuff like that. But the question is just to calculate it and not worry about that. So looks like I'm getting answer A again. So to show you the thing that I'm avoiding here. I'm trying to find it. Yeah, the thing that I'm avoiding, so I don't even understand it for myself. I've seen explanations for it before, but I don't remember them. This is the general formula for the determinant of a matrix. It has this weird sign function of sigma, and you have to learn what sigma is, and it's just a very odd formula. And so usually when they teach you determinants, they show you tricks like what I just showed you, because this formula is very just difficult to use. That's it. So it's a really useful thing. the cross product. And sorry, Ghost Gamers, I see the question you put there. I don't think I can solve that one. There's one more chapter to read, and then I have project to work on. Fun. Nice. Is there another key part to this? So cross products are a really like important and cool thing. What they do for you is if you have any two vectors in three-dimensional space, they give you a third vector that's perpendicular to both. So let's say I have a vector A and a vector B. If I take the cross product of them, it's going to like it's hard to draw this in 3D on a 2D page, but it basically the cross products will pop out of the page towards you and be perpendicular to both. And that's a really useful vector to be able to find for a lot of things. A simple thing would be if you want to talk about a plane in 3 dimensions, they're defined by their normal vector, which is the vector that's like perpendicular. And I'm using a lot of terms here that you might not know, and I apologize if you don't. And so if you have two vectors that like lie inside of a plane, you can figure out the equation of that plane using the cross product, is what I'm trying to say. You get it? Okay, good. That's what cross products did for me. What have they done for me lately? I haven't studied this part of math, but you do like graduate past these at some point in math that I haven't reached. Or they're a little bit like narrowly defined, maybe. And so when mathematicians try to generalize things, they don't really generalize nicely. So yeah, these do have a real use, but the question that as they asked it ignores all of their coolness. Yeah, Ghost Gamers, I'm sorry, I saw that, but that's a really complicated question that I don't know how to do, so I can't do that. Okay, so let's see if anything else on number 4. Let's read through number 5. Which most accurately describes the shape of the curve modeled by the polar equation r squared equals 9 cosine 2 theta. Ooh. I don't know my polar coordinates well enough. I don't remember. I know lemniscate looks like infinity. I guess that's all I need to know. And a lemnicon is going to look like a circle or heart. Really, what I do with this types of question, or with a question like this, is I just do some test points and graph it. I bet there's something crafty you can do here with finding symmetries in this equation. I don't really see them, though. It's an infinity? Okay. That makes sense because of the squares. Well, so since you can already tell it's a lemniscate, the only question is to figure out the width. Well, how do they define width? Do they mean width of the entire infinity or just one of the pieces? I assume they mean the entire thing. For that, we can just plug in points, though. R squared equals 9 cosine 2 theta. I bet it's going to be width 6. And the reason I'm saying that is that if I take the square root of each side, 3 root cosine 2 theta. At best, cosine, no matter what you plug into it, cosine can only be a maximum of 1. So at some point, r will equal 3. And at the same time, it'll also equal -3. And that's the most it can ever be. So the entire width is going to be 6. And so assuming they do mean width of the entire infinity and not just like half of it or something weird, like this distance here is going to be 6. You can even go to Desmos too and verify that, but I'm going to say the answer is B. The same thing is true with sine as well. So sine is at best only 1 or -1. It's B? Okay. I guess I don't need to go to Desmos, but you know, they're always just fun to look at. Well, polar coordinates are fun. Why do you hate me? Oh, you don't like... Ugh. You have a lot of these? Oh, wow. There we go. Yeah, it goes out to 3 on either side. Is this like a high school competition math? I'm assuming it is from the little thing at the bottom there. Oh, nice. But yeah, so if you're gonna have a lot of questions like these, I highly recommend you check out like the other streamers on Twitch too, because I can definitely keep on helping with these. But I'm not always around, so there's a really cool community of people here who can definitely do questions like these. Stats on these tests, does that piss me off? Yeah, this would be... You said it was 60 questions in 60 minutes. This would be... Giving a cross product is so mean. Unless you, I guess, do the trick that Zach said. Yeah, like, this would be doable for me. Like, I think I could do okay on this if I just suddenly had to take the test right now, but I definitely would not be getting a perfect score on this. Um... Maybe the last one today before I wrap it up and go eat some dinner. You guys gonna have both of these? Okay. Oh, there's even stats on this. Wow. The scores for students receiving the AP stats test last year above the national average. After researching, found the national exam average for last year was 2.89. Should you say the null hypothesis of our students' scores are higher than the national average? Okay. So with stats, you have the null hypothesis, hypothesis, which is H sub 0. The null hypothesis is like the status quo. Ghost Gamers, I think I can do a question from you if that's what you're asking. That your questions are going to be too hard for me, but I'm probably going to wrap up these two questions on screen here. Oh, well, the answer is just B. Well, what? Oh, wait. Oh, they do a different convention. They might do a different convention. Oh, I hate that. Okay, so the null hypothesis is basically the status quo, nothing special is happening. In this case, it would be the AP Stats teacher's students did not do like better than average. Like, there's nothing special about her class. Would be the null hypothesis. It's A. Oh, disgusting. So the way that I was taught and the thing that I like is the null hypothesis should always use an equal sign. This test begs to differ, and I don't like that. So I was going to write always has an equal sign, but that's just not true. For in their world, and they're wrong. The other one is the alternative. What? Excuse me. I was using you. You just disappear on me like that. The alternative hypothesis. I guess they're using H sub A. I don't remember. I think I use H sub capital A. So I think some people use H sub 1 too. So the alternative is what you're trying to prove. In this case, the teachers, students did do better, and the two are always opposite, and so that idea of opposites is why some people do the convention. Freaking thing. So the fact that they're always opposites makes some people prefer this convention where you use not necessarily an equal sign. I don't like it. But some people do it. So how I would think about this question is I start with the alternative because that's pretty clear cut here, which is the teacher wants to know if her students did better than average. So that implies mu, the mean scores of her students, is greater than the national average. So that's why this alternative is the right one to choose. And then the null is just take the same thing, but make, instead of a greater than, take the opposite sign, which is less than or equal to. So yeah, that's how that works for stats, I guess. I don't know if you have a question on that. 44 is just a thing to know, unfortunately. Arctan is a neat function that comes up a good bit, so it's worth knowing how its graph looks. Come on, this thing is the document's getting too big, so it's starting to lag a little bit. So arctan looks like this. It has two horizontal asymptotes at pi over 2 and minus pi over 2. And if you can't remember this, remember that the graph of tangent, or if you do remember the graph of tangent, you can take this and reflect it across y equals x. Technically tangent is periodic, so there's a lot more. For the sake of inverting it, we ignore these, but yeah, our arctan is just a graph that's worth knowing. It comes up often enough. And so the reason that's pi over 2 is that x is going, actually, it's, if you haven't learned limits yet, what this means, the limit as x goes to infinity, it means we're looking at x values that are very far to the right. And so the farther right we go, the closer we get to pi over 2. We never quite touch it, but we can get arbitrarily close to pi over 2. So we say that in the limit as x goes to infinity is just pi over 2, because we can get as close as we want. Okay, so then we have a question on, I guess, either of those. If not, I think that might be it for me for the day. Simple calculus just for stuff like this. Power rule, chain rule, L'Hopital's. Okay, nice. Yeah, if you want to help with that stuff too, me and pretty much anyone in the list can help with it too. Sounds good. Yeah, feel free to post stuff in the Discord even if I'm not on stream. I can't promise that I would, and like, if you post it when I'm not streaming, I'll get back to you in text. I can't promise that I'll do it like immediately or anything like that. But yeah, you're welcome to post things offline as well. Someone else might jump in and help too. Yes, it sounds good. These are like pretty decent questions. And they're actually pretty doable for me, which is a nice change of pace from the questions some people ask. Okay. I think that's it for me then. I want to eat. So YouTube stream, I'm gonna cut that off here. So anyways, here on YouTube, thanks for being here. On Twitch, we'll look for a raid.